Let's go over using graphs to relate to quantities. Alright, so let's say we have just a graph, any graph, and then whatever this is, like let's say this is time, typically we use time here, and then this is any other value. So at the beginning here, time is 0. So whatever this value is the initial value. So for example, this is a bank account. This is how much money is in the bank account in the very beginning. If it's water in a pool that's being either filled or drained, this is the initial value of water in the pool. If we're down here, then that means that the initial value of whatever it is 0. Here we show some initial value greater than 0. Now, as time goes on, this is going to change. So if it goes horizontally, that means that the value is remaining the same. As time goes on, that value does not change. So if this represents the water in a pool, the water in a pool is remaining the same level as time goes on. If we start to fill it up at a constant rate, it's going to increase. Okay, and what's very important is that this has to be a straight line if it's a constant increase. Okay, the slope is the rate of change. So if it goes up at a constant rate in a straight line, it's being filled at a constant rate, or whatever is going on here, it's a constant rate. Then if it is horizontal again, that means that we stopped filling it or stopped doing whatever we were doing. If it goes down at a straight line, this is a constant decrease. Alright, so what does that compare to? Well, this is also an increase. It's going up, right? It starts off low and then it goes all the way up to this high point. But this is not constant. It's not a straight line. This would be a constant increase. This is not a constant increase. Similarly, this is also not a constant increase. We are increasing, but it's not increasing at a constant rate. Let's look at an example of something that a student's doing after school and plot his distance from home. So let's make this time in minutes. So 0, 1, 2, 3. Alright, so this student starts off 20 meters from home. So when time is 0, the student is 20 meters away from home. Then he runs farther from home for 2 minutes. Spends 2 minutes running farther from home. So his distance from home is going to increase during those 2 minutes. And then he's going to stop and talk for 1 minute. So since this is his distance from home, during that 1 minute, his distance does not change. Whatever it is, it stays the same for that whole minute. Then he walks home. So see how the steepness of this? This is his rate of running. So if he's running, this should be one steepness, and walking home should be less steep because he's not going to travel as far in as much time. So it's probably going to be something like this, much less steep, and probably off of my graph that I made. So somewhere down here, maybe 10 minutes later, or even 12 minutes later, he arrives back home. So running, it's going up at a fast pace. His distance is increasing quickly. Took a break. Then walking home, his rate is much less, and it's negative because his distance from home is decreasing, and then finally down to a distance from home of 0.